All right, so here's your review for Module 6 and 7 tests. Start by working through this. So first one, identify for the following parabola f of x equals 2, x minus 3 squared minus 8. So this is vertex form, so fairly easy to pull our vertex. We're going to be at 3, negative 8. Remember, the formula is x minus h squared. That's why that negative 3 is a positive 3. Then our axis is x equals our x-coordinate of our vertex, which is 3. Maximum or minimum, since our A is positive, this is going to be a minimum at y equals negative 8. That's our y-coordinate of our vertex. Our stretch for this case is going to be narrow because our A is greater than 1. To find our x-intercepts, we're going to substitute 0 in for y, which in this case is f of x, and solve. So I'm going to add 8 over. And then divide by that 2. And so then we end up with 4 equals x minus 3 squared. Take the square root, and you get plus or minus 2 equals x minus 3. Write your two equations. X minus 3 equals 2, and x minus 3 equals negative 2. Add that 3 over, and you get x equals 5, and x equals 1. So remember, our intercepts we always write as coordinate points. So in this case we get 5, 0, and 1, 0. For our y-intercept, we're going to substitute 0 in for x. So f of x, which is just our y, equals 2, 0 minus 3 squared minus 8. Simplify 0 minus 3 is negative 3. Negative 3 squared is 9. 2 times 9 is 18. 18 minus 8 is 10. So then our y-intercept would be 0, 10. Domain is negative infinity to positive infinity. Our range is y is greater than or equal to negative 8. It comes from our y-coordinate of our vertex, and since we are concave up, or we have a minimum, it is greater than. You could also write it as negative 8, starting from the negatives, working your way up to positive infinity. Number 2, axis is symmetry. Remember, for axis is symmetry, we want to do x equals negative b over 2a. So in this case, our b is a negative 12. So notice I still have the two negatives there. And then our a is 3. So two negatives make a positive. 2 times 3 is 6. 12 divided by 6 is 2. So our axis symmetry is x equals 2. Notice again it's x equals. Make sure we write that properly. Then for our vertex, we just substitute 2 into our equation. Two squared is 4. 4 times 3 is 12. Negative 12 times 2 is a negative 24, and then plus 1. 12 minus 24 is a negative 12, plus 1 is a negative 11. So then our vertex is at 2, negative 11. Okay, so graph the following equation. So another vertex that we want to graph. So our vertex is at negative 4, negative 5. Since our A is 1, which is positive, we again have a minimum at y equals negative 5. Axis symmetry is x equals negative 4. Our stretch is normal in this case because A is 1. And then find our zeros. So I'm going to substitute 0 in for y. and you get x plus 4 squared minus 5. Add that 5 over, and you get 5 equals x plus 4 squared. Take square root, and then the square root of 5, since we actually want to know these points, you plug into a calculator. And so the square root of 5 is 2.2, and that equals x plus 4. Don't forget plus or minus. Subtract that 4 over, and just like we did before, you can write your two equations. And so you get negative 4 plus 2.2. Which is negative 1.8, and then negative 4 minus 2.2, which is a negative 6.2. So then we would state that our x-intercepts are negative 1.80 and negative 6.20. Y-intercept will substitute 0 in for x. Zero plus 4 is 4. 4 squared is 16. 16 minus 5 is 11. So then for our y-intercept, we get 0, 11. Domain is negative infinity to positive infinity. Range is y is greater than or equal to negative 5, since it's opening concave up. Or again, you can write it as negative 5 to positive infinity. And then we want to graph it. So our vertex is at negative 4, negative 5, so plot that. We are concave up, and you're going to get something that looks like that. All right, so we want to use the table to write the equation in standard and vertex form. So we need to identify our vertex first. So I have 0 and 0. 9 and 24 don't match up with anything, but we get negative 3, and then we go back up to 0. So this ends up being our vertex. So then we know we at least have y equals, we don't know our a value yet, but it is x minus 2 squared minus 3. Find our a value, substitute some other point in. I'm going to substitute in 1, 0. So I get 0 equals 1 x minus 2. Oh, totally messed that one up. You get 0 equals a 1 minus 2 squared minus 3. So 1 minus 2 is a negative 1. Negative 1 squared is positive 1. So we get 0 equals positive 1a minus 3. Now, one issue a lot of students do is they go a1 minus 3, and then you combine that, and all of a sudden we have negative 2a. But that is not the case. That 1 is multiplied to the a, and that is not a like term with the 3, and so we don't combine those. So to solve, I'd add 3, and we get 3 equals a. So then there's my vertex form of that. Now, standard form, we're going to take our vertex form and distribute that out. So remember, it's x minus 2 squared, so we go x minus 2 times x minus 2. When I distribute that out, you get x squared minus 2x, and then plus 4. So then we get x squared minus 4x plus 4. Now, a lot of students stop here, but they forget about everything else that's happening in this equation. There's a 3 out in front and a minus 3 at the end. Order of operations, I need to distribute the 3 first. So we get 3x squared minus 12x plus 12. And then we can subtract that 3 to give us our standard form equation of 3x squared minus 12x plus 9. All right, so as you look at number 5, so it's a function equals x squared is transformed into the function g of x equals 1/3 x plus 7 squared plus 2. So we're going to determine whether each statement describes the transformation. So the graph is shifted right 7 units. So we do have 7, and it is in our H, which shifts left and right. But our vertex for this would be -7, 2. And so the graph is not shifted right 2 units. It would have been shifted, shifted right 7 units. It is actually shifted left 7 units. The graph does get wider because our A value goes from 1 to 1/3. Our vertex is at 7, 2. Again, same issue as A. That is not correct. And then our graph just shifted up 2 units. So our K value does shift up and down. And in this case, it goes the direction of the sign, so it is positive. So this would be yes. All right, so looking at this one, we want to describe the shift in the parabola from x plus 3 squared minus 2 to the parabola x minus 5 squared minus 4. Easiest thing I think to do is look at our vertex. So we get -3, -2 for this one, and +5, -4 for this one. So then you look at how do we go from -3 to 5? We're just going a number line. So that's a distance of 8, and that's our x value. So it's left or right, and we're going from -3 to +5. So that is 8 units to the right. So that's either that one or that one. So then we figure 8 units to the right. So that one. So now we just got to figure, are we 2 units up or 2 units down? So we're going from -2. Okay, so looking at this graph here, so there's -2 and we're going to -4. So that is down 2 units. So then our answer would be E on that one. All right, so graph the following equation. So as we look at this, there's some things we can do fairly easy here. This is what we call factored or intercept form, which means my x-intercepts are easy to find. So 2, 0, and -6, 0. I come just from those x minus 2, set that equals 0, x plus 6, set it equals 0. So then we can plot those. That is at 2, 0, and -6, 0. Now our axis is symmetry. Symmetry, remember, means right down the middle, mirror image, cuts in half, however you want to do it. So we want to find the middle of this. A couple ways you can do it. You can count. So 1, 1, 2, 2, 3, 3, 4, 4. So it would be right there. You can also add the 2 and then divide. So -6 plus 2 is a -4. Divide by 2 gives us -2 as well. So that becomes our axis of symmetry. It's also our x-coordinate of our vertex. So then I can take that and plug that into the equation to get my y value. So I get -1/2, and then -2 minus 2 is a -4, and then -2 plus 6 is 4. -4 times 4 is a -16, times -1/2, which is +8. So we're -2, +8, which then, as we connect our points, that also gives us some other information. So vertex is at 8. We have a maximum because we can see our parabola is going down at y equals 8. We also could have known that because our A value here was negative, so that is concave down. Our stretch is going to be wide because our A is 1/2. Our y-intercept, now we got to do a little bit of work. So we're going to substitute 0 in for x. So we get 0 minus 2 and 0 plus 6. So then you get -1/2 times -2 times 6. -1/2 times -2 is a +1. +1 times 6 is 6. So then our y-intercept is at 0, 6. Domain, just like before, is -infinity, +infinity. Our range this time is y is less than or equal to 8. Or, remember we start with negatives, so it would be -infinity to +8. All right, number 8, what are the x-intercepts of this graph? And so remember, in order to find x-intercepts, we're going to substitute 0 in for y. And now this just becomes our factoring. We have 3 ways we can do it. We can factor, solve by square roots, or quadratic formula. And in this case, all three of those would work. If I want to solve by square roots, I'd add 25. You get 25 equals x squared. Take square root, and you get plus or minus 5 equals x. So it'd be that and that. Or if you wanted to factor, if you factor, you get x minus 5 using difference squares and x plus 5. Once you set those equal to 0, you can solve from there. All right, so now writing an equation. And so we're going to do it in all three forms. I like to start with vertex. And there's my vertex there. So I get y equals our a value, which you don't know yet. And then we get x plus 1 squared minus 32. And to find our a value, we can substitute any other point in. I'm going to substitute 0 and negative 30 in. So I get negative 30 equals a, 0 plus 1 squared minus 32. 0 plus 1 is 1, 1 squared is 1. So again, we get a, and then minus 32. Add that 32 over, and 2 equals a. So replacing that a with a 2, and we get that there. So now we know our a is the same all the way through. So when I look at intercept or factored form, I know I'm going to be y equals my a, which is 2, and then x minus and x minus whatever my intercepts are. So I have one intercept of negative 5 and one intercept of 3. And then on this one, two negatives here make this a positive 5. And then standard, we have our a already. Easiest way is just to multiply out one of these. You can do either version. I like standard, vertex form. Make sure you write as x plus 1, or you can do intercept form, which I haven't done yet, so I will do that version. We still just distribute. So I get x squared minus 3x plus 5x minus 15. And we get x squared plus 2x minus 15. And then distributing that 2 in, we get y equals 2x squared plus 4x and then minus 30. And there's all your problems.